Okay, welcome everyone. Thanks for coming out to this session. Today we're talking about 3D visualization with the ArcGIS API for JavaScript. And before we introduce ourselves, I just want to get a feel for some of the things you've done already. How many of you have not used the JavaScript API? So just a couple, okay. And how many of you have attended the 2D visualization session at Dev Summit? Okay, great. So think of this as the 3D side of it. We're not going to talk 2D. It's all 3D thematic visualization. We'll also talk real world visualizations, things of that nature. And with that, I'll just introduce myself really quick. My name's Christian Ekenis. I work in Redlands at Esri, product engineer on the JavaScript API. And I work mostly on the 2D visualization side, the smart mapping project, and I'm also got my fingers in other projects such as Arcade. And I don't think we touch on Arcade much in this session, but there is a strong visualization story with Arcade. So I encourage you to go to the Arcade session at 1 o'clock today, because we talk a lot of viz there as well. A little bit of 2D, a little bit of 3D in that session, so I encourage you to go out to that. And I'm here with Raluca as well.
Hi everyone, my name is Raluca. I'm a product engineer for the JavaScript API. I work mostly on the 3D side of the API, and I work with a team, an R&D center in Zurich in Switzerland. So let's just jump right into it. This is why you theoretically should be here, so if you're not, this is your chance to stand up and leave. Basically, these are some visualizations that you could do in 3D. We're not gonna talk about all of them. We're gonna tackle this use case where you wanna visualize points of interest in a city. We worked on some nice features that will help you with that, and I wanna show you how it works. Then Christian will introduce you to smart mapping and show you how to use it for thematic visualization in a city. And last but not least, we will talk about the urban development use case, and I will show you a new feature that we have for this release in April, the edge rendering. I'm gonna go for 5 minutes into the visualization API basics. Even if you all seem to be familiar with it, I'll go fast through it just to make sure that everybody's on the same page. Then we'll talk about the 3 use cases that I mentioned before with some hands-on demos. And afterwards, Christian will give you a general overview of symbols and renderers and what kind of visualizations are possible, just skimming through them. And then I'll come at the end to give you a sneak peek into the future and show you what we are working on in Zurich. So the basic patterns for the visualization API are like you have a layer, and in order to change the symbology, you need to set a renderer on it. And on the renderer, you can specify the symbol. And in 3D, we have this concept that you can have several symbol layers for a symbol. So in our case, like if you want to visualize icons as points, you would have a point symbol 3D with an icon symbol 3D layer. And the idea is that in the future, you will be able to add several symbol layers to the same symbol. So that's why we introduced it. You might be familiar with this concept from like ArcMap or like desktop applications where they also have this. Another important concept that you need to know is like we have this visual variables property where you can map numeric continuous attributes to, for example, color or size or opacity or rotation. And this will allow you to create multivariate visualizations. The visual variables, again, you set it on the renderer. And these data-driven visualizations can be done like in my previous slide here. You could see that I have this field. You can set a field, or you can use an arcade expression so that you don't need to pre-process your data, but you can actually use like calculate a new value based on several fields, and this is really powerful and it allows you to be quite flexible. Or the third use case that it's not really that much use and we don't really encourage too much is to actually write your own JavaScript function in the renderer that will be able to, like you will have to return a value. For 3D, there is another important property on the layer that will be useful for you for visualization. It's called elevation info. And there are several modes that you can set. So I made this small illustration here to help you understand it better. If the blue points would be my point feature layer, if you use relative to ground, then your points will be aligned to the ground elevation that you have in your scene. If we assume that the yellow representation here are buildings, we would call that a scene layer. And in order for your points to be visible, you would have to set them relative to scene, and then the points will be set at like what is higher, like the scene layer or the ground layer. So basically they will align to your scene layer and your ground elevation. And then you might also have the use case where you have your own set values. Then you would have absolute height, and then the points would be placed independent of where the ground is. They would be placed at the height specified in the geometry. There is a fourth elevation mode, which is called on the ground. You can see it here on the lower left. And what this does, it's draping your features on the ground. So it basically converts them to a raster, and it puts the raster on the elevation. For points, this is, I rarely use this. I prefer to use relative to ground because then they're like billboarded, and then you, like they are in 3D basically. Another important feature is labeling that you can do also by setting this labeling info on the layer. And then the concept is the same. You would have a symbol, which is a label symbol 3D, and you would have to add a symbol layer, which would be your text symbol 3D layer. And that's how you would add labels to your features. So these were like the basic concepts just to get you give you an idea of how this works. And now I can just start with the 3 use cases. The first one would be, how do I visualize points of interest in a city? And I have already my scene prepared here. So you can see that in 3D, quite a big problem is occlusion. So if you have buildings and points, and you would map them relative to ground, then the points would be hidden by the buildings. So how to better do this? I think I'm just gonna split my screen and then just move this here. This is also a sample in the API. It's basically just it's a single file. I have a web scene. I load it in the API. Then I make sure it gets visualized in the scene view. And this is the unique value symbol function that gets passed to the renderer. Here is where I get my symbol. And then the renderer gets passed to my points layer, which are these points here, like the points of interest, museum, restaurant, church. And then the points layer gets added to the map. And I also create the legend so that the user understands what those points are. And the first thing that I mentioned was that these points get hidden by the buildings. So with this new elevation mode that we introduced, you can set it to be relative to scene, and then you can see that some points will already be now on top of the buildings. So you see they get pulled up. And this is good, but it's not enough, because like if you have your points like the way you see them here, you're not really sure like where is this point? Is it on this building or is it on the one behind it? Especially if you tilt it a bit more, it's quite hard to figure out where they are. So what we did, we introduced this what we call the callouts on the points and the vertical offset. So the vertical offset will shift your points by a certain offset that you give in, And then the callout will basically connect the original position of the point to where it is right now. So if I'm going to comment out this code, you will see that it's much easier to interpret where the point is if it's basically a line that leads you to the actual position, the initial position of the point. So this is one thing that we introduced. You can specify for the callout the color, you can set a border, you can set the size. I made them quite like in your face, quite thick so that you can actually understand what they are. For the vertical offset, so in 3D we usually have like screen space and real world size elements. And this callout, this vertical offset is a bit of a mixture between the two because you see you have the screen length. But if I would only have the screen length, the moment I would zoom out, they would be like you would have the feeling they keep on growing and growing. So basically what we do, we set this max world length to ground them to 200 meters. So if I zoom out and my callout will be bigger than 200 meters, taller than 200 meters, then it will somehow stick to that elevation. And the same thing applies for min world length. If I would keep on zooming in, then and you would always see 80 pixels, then when you zoom in, you will have the feeling it always goes lower and lower. So then what we do, we make sure that it will never be lower than 35 meters in real world space. Yeah, this is for the callouts. Then another thing, like when you zoom out, this is like so crowded, you basically don't really understand much. And for points of interest, I'm not really interested like in this aggregation of points or anything. So what I'm interested is just to filter them out. And when I look at the whole view of the city, I just want to see maybe some of them. And then when I zoom in, I actually want to see them all. So we have this new feature that we call feature reduction. And it selects features, I could say randomly, but it's based on which are closer to the screen. So now they deconflict and you don't get this super crowded, full of labels, full of icons view. And the moment you zoom in, then you start getting more features. Another thing that in 3D is really important is this perception of the depth. So for example, you can see this icon has the same size as this one here, which is a bit contradictory because in 3D you would expect that what is further away is smaller than what is closer. So this is why we introduced a new property with this super long name, screen size perspective enabled. And per default, it's turned to true. It's set to true, so you will get that automatically when you create a point feature layer with icon symbols. But I set it to false just to show you the difference. So now, for example, you can see that these icons here in the back are way smaller than these ones, and your perception of 3D is like much better. Your perception of depth, sorry. We wouldn't recommend that you use this, like if you use size visual variables, if you have some thematic data that you want to map and you use size visual variables, don't use this because it will really mess a bit with your visualization. But definitely use it for these use cases when here I have categories, so I don't have any numerical values in there, and I have more or less a realistic view of the city. It's a bit of a combination between realistic and cartographic, thematic. So I think this comes in very handy. And yeah, that's about it, like what we have for point styles. Christian, you want? Yeah. So Christian will talk about smart mapping in city visualizations.
All right. So a number of you already indicated that you came out for the 2D session. I just wanted to show a few samples first before we dive into smart mapping to kind of talk about the need for it. So flip over to my screen here. This is just our documentation page. If you haven't checked it out, I strongly encourage you to look at it. We have a bunch of samples. We try to spend a lot of effort on our API reference to make it good. But if you take a look off to the left here on this TOC, you can see that we organize these samples based on a number of topics, layer types, and other things. But we have a visualization tab, which has a bunch of visualization samples that allow you to explore what you can do in 2D and 3D. So let me refresh this sample just to give you a sense of what you can do. I alluded to this at the beginning. I like to think of 3D visualization in two categories. There's thematic visualization, where you use the 3D space to do some kind of numeric or categorical visualization and do something like this, where we have county data and we can extrude the shape of the county based on an attribute value. So in this case, it's the percentage of the population in poverty is what's driving the color, but then we have the total population in poverty that is driving the height of the county. And I just want to point out a couple of issues with this visualization. First of all, when we get into bivariate mapping, such as this one, we're looking at two variables here. We're looking at a percentage, and we're also looking at a total. It can get it's already confusing in 2D for people, but once you bring it into 3D, you just add this extra dimension of confusion. And so when someone immediately looks at this, they might think they're looking at buildings, they might think they're looking at something else. So you just need to be aware that there's going to be this element of confusion, so the communication might be a little off. And ultimately, when we talk about data visualization or data viz, communication is so key. If you're not communicating your message, then ultimately the visualization fails. So we try to do our best. Just want to be aware of that. None of these examples are necessarily perfect, but they should be a guide to you so you can learn how to do it with the API and hopefully be inspired by it. Another issue you'll notice, Raluca alluded to this one, in the scene view, so this is a 3D view, so you see the horizon off there and some stars in the background. This brings an aspect of lighting into the scene, and that lighting is crucial, so we get this realistic look so it looks like it's 3D and not some kind of weird cartoonish visual. So you'll see that if you look at one feature, say this one right here that I'm going to click on, mobile. So if I unclick it, you'll see that shape, that 3D object or extrusion, has 3 different shades to it. And those shades allow you to view that as a 3D object, right? Or an extrusion. However, you'll notice that on the legend, it only pertains to one color. So we actually have 3 different colors on one feature. And so using the legend, you can already, if you're any of your cartographers out there, you're gonna already see this is a problem. If depending on how I look at that feature, I can't match that color properly to the legend because the legend doesn't reflect the lighting at all of those angles. So again, that's another issue for those purists of you out there who are used to 2D cartography. And also the size in the legend, I mean, clearly that doesn't represent what's actually going on in the view. I can't measure that extrusion that shows 150,000 as the population and then compare it directly to the view as you would in a typical 2D printed map. The purpose of this legend is to just give you an idea of what's going on. It's not intended to be taken literally when it comes to size and even color in that aspect, but it should give you a pretty good guide so that, I mean, because this is a web map, we can click on it and get the actual values in the pop-up, and so we don't have to rely so heavily on that legend. So I just want to make that clear. Those are some things to be aware of. Those might be some things your users might be irritated by, so just be aware of that and be prepared to explain that to them. That this is something that, 3D cartography is still relatively unexplored. There's so many things we're still trying to figure out, so that's what's going on. Also notice, again, for those of you cartographers, we're showing areas, so we're using the actual shape of the polygons. There's different ways you can approach this with our API. So if I scroll down, as Raluca talked about, she talked about the render, the symbol layers. Just want to note that we're using extrusion here, but we could easily change this to an object symbol 3D layer, refresh the app, and get a different type of visual. And so now we get these sized bubbles per se, but again, that may convey the wrong message, may not make sense, so you can maybe change the resource. We have a number of primitives. So instead of, say, spheres, we could say, I want a cone, and it'll give me something that looks like this instead. But again, these look like mountains, right? They're not, I don't look at this and say, oh, this is poverty, right? And so if you can just play around with this a little bit and say, I want maybe the width of these symbols to be 20,000 meters. And again, when we're talking about 3D shapes and thematic data, we're using real world sizes, and that gets a little weird for people. So I just want to point that out, that this is what's going on. And so let's say that we make and also when we talk about size, you'll notice that I didn't type in a size property like we do in 2D. In 3D, we actually have 3 different properties for that. We have a width, we have a height, and we have a depth property. So it allows you to size these objects in different ways. But let's set the width to kind of a static 20,000, and we can we can apply that to all of our features using a size visual variable. And I'll set the axis here to width. And then I'll say, just make sure I'll check the doc here, use symbol value, true. So in that case, it'll apply that same width to all of my features. Right now, they're just scaled proportionally based on that population and poverty variable. And so on this one, I can set my axis to just height. And I should have maybe something that looks better, maybe something that doesn't. So you get something that looks like that. And we have a 2D way of doing this where we indicate size for polygons by using the centroid. This is sort of the 3D way of doing it. And again, this is bivariate, so it gets a little confusing to look at. So you could do something where, maybe we set the size and the color to be the same value. So or the same variable rather. Oops. So yeah, let's go color, and then I got rid of my colors. There we go. So let's use 1,000, and then 150,000 for this one, and get rid of that normalization, and let's just say the population, total population, refresh. Hopefully we get something that looks like it's showing both. So now, commonly, you might see this where we map 2 variables with the same, we might map 1 data variable with 2 visual variables, so to speak, so we're using size and color. In traditional 2D cartography, this is usually frowned upon, but we found that in 3D, it's very helpful to see because of the depth, as Raluca talked about, because of the color differences, because things, this feature back here, some people might want to compare it to something up here and say, oh, well, this, because of my depth perception, it looks smaller, and I want them to be the same size, but we don't want it to do that because it would look goofy, so we apply color to help you out, help your eyes out there, help understand that. Now, a lot of you are looking at this, okay, these are just a few properties they're messing with. API looks relatively simple, but again, I'm not a cartographer. I don't know what colors make sense. I don't know what sizes make sense. It's really strange that you're using meters to indicate size as opposed to pixels or points. So how can I get help in this realm? And that's where smart mapping came up. So we've been playing around with smart mapping in 3D, where the idea is, okay, you don't know your data very well, maybe you don't know colors very well, but give me a layer, tell me a field value, maybe an arcade expression, and give me a base map that you're going to use, and we'll pick a good color scheme for you based on the base map, and we'll query your data for the stats and give you either a size visual variable or a color and size visual variable that makes sense for that data. So that's what's going on here. And you can even hook it up to these sliders and change them and allow users to explore their data. And again, when it comes to 3D visualization, showing this to a number of people, it gets a little confusing for them. So it's something we're experimenting with. We're trying to refine it, play around with it a bit. So just be aware that while cool, just make sure you're communicating the right message. So if we pop into this, you'll see that I just have a number of parameters. When we're talking about 3D smart mapping, we require you to pass in a view parameter as well, because we choose the sizes based on the scale or the distance from the camera that your features are. And you also need to indicate what type of symbol. If you say 3D volumetric, it means you're creating these cones or these cylinders or spheres. If you set it to a flat symbol layer, and we'll talk about those a little later, you're going to get more of a 2D symbol. So you just give it your layer, tell it what base map you're working with, give it your field, and then you just pass that into this create continuous render method, and it will spit out this renderer for you. And you don't have to worry about setting those stops. You don't have to worry about choosing your colors. It just has that right out of the bag for you. Now, just a word of caution, you don't want to do this in all of your apps because you don't necessarily know what you're getting, right? You might trust it. You might say, hey, I'm probably getting something that looks pretty good. And you, I think, are right 90% of the time, but it may not be what your users want. And you're also impacting the performance of your app because you're making a query to the service each time that it loads or each time that you change or that you call this method. And so that's just an extra network request that you're dealing with. This is really intended for data exploration apps. So if you provide this to your users or you want to play around with it yourself, you can be like, okay, this is about what I want to show. Just go ahead and export that render or save it, and then just save it to your layer or reference it in code, load it from JSON, whatever. That way you're not dealing with this network request every time. My favorite aspect of smart mapping, let's see if I can find, is using it on 3D objects, scene layers. I think it's cool to do it with points. We don't support lines yet. That's coming in the future. It's cool to do it with points, but I think it really shines with the buildings. And so this is a case where we have buildings that have been enriched with walk times from transit stops. And I don't know, again, necessarily what the data looks like. And so I just want to see I just want to visualize on a high to low ramp what buildings are within 15 minutes of my transit stops. And so I use smart mapping to generate that with the same method, but I also provide this UI element allowing the user to switch the theme. So maybe instead of the high to low theme, you want to do centered on. I'm not sure why the slider's not updating. It should. So if we refresh it, oh, and then it's not even there. Oh well. So you get that visual right out of the box, and then you give a slider to your user, and they can play around with understanding those buildings, and maybe they do like different themes, and they can explore their data. So it's pretty cool stuff. Am I talking about edges next?
I'm going to talk about edges.
Okay, cool. So again, this is not intended to be a final visualization. It's supposed to give you a good starting point. So after Raluca talks, I'll show you another app using the same data that gives a final visualization that is probably something that would be the end result of, say, using smart mapping in your apps. So, Raluca?
Cool. Thanks, Christian. So what Christian mentioned before about the lighting and how it can impact the color of your features, we were thinking, how can we actually make this better? And the lighting is the only thing that like the shading of the buildings is the only thing that actually gives you the 3D perception. But we could actually add something else to it that could tell you exactly what is the shape of the building. And I like to browse through Pinterest image, and I saved these ones, and I realized these look really good. And what they have in common is that they show the edges of the buildings. So in these three cases here, like this one and the lower ones, you have some thematic data, or you have this how to say, cartoonish representation of the data. In the upper right one, it's more like this urban planning, sketchy kind of feeling that you want to have for a use case when you want to present a project that you want to create that is not there yet. So for these use cases, we thought, wow, edges would be really cool. So I'm going to show you a demo on how, we implemented this and how it helps with the visualization and how it helps to actually better understand the shape of the buildings. The next step for us would be, for the next release, would be to actually give the users the opportunity to fine-tune the lighting, and then you won't really have this difference in the color between the legend and what is actually displayed on the map. So let me show you how easy it is to set the edges. This is my app. This is how it currently looks in 4.6 in the API. And here on the left, you can see, oh, sorry, no, this is still the old one. Right, this one. So in this file, you can see it's a simple app. I have a web scene with the scene view, and I have two buildings layers. So the buildings layer here are the background buildings, the general buildings for the city of Zurich, and then I have a project layer, this orange buildings here. And if I would turn on, setting edges on the buildings, you do it with one property on the symbol layer level. And now if I refresh, you will see the solid edges. We call them solid because the line is a solid line, so to say. And on these ones, you could set the color. We discovered it's better if you set transparency on it. Otherwise, they're gonna stand out way too much, and you don't want that. You just want some edges to give your users the clue, the hint of what the building looks like. So it should be quite subtle. And this is for the general buildings. And then if I have a project, I might want to visualize it differently, the way I showed you in that Pinterest image. We called it sketchy. We might rename this to sketch maybe, because since I came here in the US, I learned sketchy is not a good thing. So this makes the lines a bit wobbly, and you can also set this extension length that will make them shorter or longer. It kind of gives you that feeling of hand-drawn, and this is what we wanted to achieve with it. And the API for this is super simple, so we would like to encourage you, if you have these use cases, make sure, you go ahead and try and use it. It will really improve your perception, and the user's perception of how these buildings look like. Yeah, that's it. Do you want to?
Okay, just wanted to show you this does work.
Christian fixed his app.
No, it was like a network issue. It was kind of weird. So what it does is when you call that render generator method, let me go to the code here. You have these parameters, so I'm just getting my layer. This is that scene layer. And the base map, I'm either getting it from the web scene, or maybe you could do something different. And I'm grabbing that field, and I don't want to go above 20-minute walk, so I can set a max value. And then I grab that theme from that select, and here again, I'm getting that render. So it's the same workflow you saw with the points, it's just using buildings this time. And notice that I'm also setting a histogram. It's kind of hard to see on this one because the data is so skewed. There's thousands of buildings in that layer, and most of them are outside of a 20-minute walk. So if you look at that histogram, you see that there's 32,000 that are gonna hit that max, 15 minutes or more. Whereas down here, you can hover and get the sense of all the buildings along the histogram. So I like the slider in the histogram because it allows me to see the spread of my data. But once you get a visualization that you like, it might look something like this. So you're taking the edges that Raluca talked about, and maybe you chose a different color scheme. You updated the legend to say something more nice. So it's more than a 15-minute walk, or it's less than a 1-minute walk. And you can get something like this. And just to, again, show you how the edges affect the rendering, you can toggle them on and off here. You wouldn't provide that option to your user clearly, but that's just to give you the visual difference of how useful edges can be.
let's go on to symbols and renderers, the general overview.
Okay, so we showed you a few demos. I kind of played around in the sandbox showing you how the visual variables work and everything, and I changed the symbol layers and the primitives, and you might be getting a little confused, your head might be spinning a little bit. That's what this section is designed to go into. So we have different, in 3D, we really have 5 different types of symbols, but when it comes to one of those symbols is a label symbol, so we're not going to talk about that. We're just going to talk about the 4 other symbols. We have 3 of them here. Another one is on the next slide. But you'll notice that they're all broken up into different categories. You have a point symbol 3D, a line symbol 3D, and a polygon symbol 3D. This is much different from 2D. In 2D, we have things like simple marker symbols, picture fill symbols, and all of that. And you can apply those simple markers to the polygons as well. And it's not very clear necessarily how that works. But in 3D, I think it's a lot nicer. It's a lot cleaner because you know exactly what symbol type you're going to work with right away. If I have a point layer, I know I have to use a point symbol 3D. I can't apply any other symbol type. If I have a polygon layer, I have to use a polygon symbol 3D. That's the way it is. So it keeps it nice and clean for you. Then you have a number of symbol layers that you can use within those. So Lucas said, in theory, you can actually now add several symbol layers, but we can't persist that to the web scene. And it also makes your visualization look a little weird, especially if you're using visual variables, because it doesn't know which symbol layer to apply that visual variable to yet. We're getting there, but that takes a lot more effort and research on our part to figure out how to deal with that. So right now, I typically just use 1 symbol layer per symbol, and these are broken up into flat symbol layers and volumetric symbol layers. So you see the flat symbol layers on top, and these are your 2D, you can think of these as your 2D symbols. We don't want to call them 2D symbols because it's a 3D view. That's why we make that distinction. Note that on the right, you'll see some critical information. Sizes are in screen points. So this is a lot like your 2D symbology. You're going to set your size in points or pixels, and you also note that the graphics are in screen space. So again, that kind of harkens back to that screen size units. And you'll see some examples there. You see your typical fills, you see your typical simple line symbol type look, and so you can do those same cartographic elements in 3D using those symbols if you want. Then you have the volumetric symbols. So that's what we just showed you. I showed you that sample down on the right-hand corner. That's with extrusion. And again, these are real-world units. That's going to take a little bit of getting used to if you've not already played around with 3D Viz. That makes it easier for us to know how to size things relative to other real-world objects. So you might be using a thematic visualization, kind of hybrid in a real-world visualization. And so it allows us to do those types of things. And note that you can also create these paths or these tubes with lines. And the points you can do a lot of cool things with. We have out-of-the-box primitives. We have web-style symbols, which are realistic symbols, and you can apply thematic sizes to them. You can do all sorts of things in 3D with these. The other symbol type is mesh symbol 3D. So that's what we're using in that other application that I just showed you. And I can show you that in the context of the app as well. The only symbol layer that applies to that is the fill symbol 3D layer. And that's because we can't modify the geometry of this. We're just applying a fill color. And if I go back to the previous slide, I just wanted to point out that the polygon symbol 3D can also take the same symbol layers as the point symbol 3D. But again, it has to match the geometry type. So I can apply icons or objects to my polygons. And that's what I demonstrated to you in the sandbox just a few minutes ago. And so if I switch back over to my machine, in the case of this app, you'll see that I have my renderer, and I set it to simple. This is auto-casting it as a simple renderer. And here's my symbol. So I'm applying the same symbol everywhere to my buildings. Because it's building layer, I'm saying this is a mesh 3D symbol, and I'm going to apply this fill symbol layer. And the default color I'm going to say is white. And then we also have this color mix mode property. We won't dive into that, but basically that allows you to shade your building thematically and apply different styles if you have textures applied to it. Or you can replace the textures, as is the case here. So if I replace this, is it going to show the textures?
It's not going to show.
It's not going to show the textures in this case.
Is it on? Yeah.
Yeah.
So we have replace, which totally replaces your texture. Then we have tint, which will desaturate your texture and then apply the color. And then we have like the normal texture.
Cool. And there's my color visual variable. And this is probably something that you might get from smart mapping. So again, originally you might not know what colors or values to use here, but by playing around with the smart mapping, either in the scene viewer or in a custom app, you can get those values and apply them there. And that way you're not making a network request every time you set your renderer. So we support 3 different types of renderers. There's the simple renderer, unique value renderer, class-based renderer, very similar to 2D. Simple render, you just, again, you set the same symbol everywhere, but you can apply those visual variables to that renderer, so you can thematically render your data with a data attribute, either by color or size, or different types of size, so maybe by height or by width or depth, all sorts of things. The unique value renderer allows you to categorize your data. So what Raluca showed with the icons, you might have lodging options or food options, maybe other points of interest or parks. You're going to assign those types different variable using that renderer. And then there's class breaks, which is a useful render. It tends to be more often used in print maps, you'll notice, and less often in our web maps, because we find the visual variable visualizations a lot more appealing to the eyes. Again, to the cartography purists out there, they might say, well, I can't match that color to the legend easily with the visual variable as I can with the class breaks. And again, if you make your map interactive, you can get a ballpark by looking at the color and comparing it to legend, and then when you click on the feature, you get the actual value. And so you already saw a little bit of this. You can take multiple visual variables and put them together. Again, this can get pretty dangerous. And when I say dangerous, it doesn't mean that you're going to affect any kind of app security or anything. It's just it can communicate misleading messages. It can get really confusing for users. This already gets confusing in 2D. So once you add that 3D element, just be aware that you probably shouldn't be using more than 2 visual variables at the same time, even though you could apply 6 or 7. Like, we don't limit that in the API. There are cases where something might look good. So by all means, you can explore it and try it. Just be careful that it doesn't get out of hand. Even if it looks cool, it may not be a good idea. Guess what I'm saying?
Yeah, so let's have a bit of a look of what we're going to work on in Zurich. I already mentioned the edge rendering. This is going to be in 4.7, so in 17th of April, I think we release. You're going to be able to play around with it. I'm curious how you will use it. Like here on the lower right image, you can see you can also try to make it look like a wireframe by just setting the fill opacity to 0 and just putting on the edges. So there are several use cases. We're really curious how you guys are going to use it. Then the lighting conditions is something that we've worked on. So these are like images from a research project that we did in Zurich, or a focus project, how we call it, where one dev sits 2 weeks and works on this, and then we see if it's really worth implementing or not. And this has really good results, and I think it's really valuable that the user is able to fine-tune the lighting so that the colors also end up matching the colors that he wants to set. And this combined with edges will allow you to actually be able to keep the colors that you have in your legend and also visualize them in the scene. And otherwise, another request that we get is that people want to change the background. Sometimes they don't want to have the sky with the stars because they want more of a thematic visualization, and this is also part of this project. And we hope we'll get it done by UC, but as I always say it, I never want to make promises because sometimes we get like requests, we need to do this fast, and then something gets in the way. Another thing that we want to work on are line styles because they are a bit different in 2D than in 3D. I don't really have awesome screenshots here because we didn't really work on any prototypes so far, but I can tell you one thing that we're gonna for sure make a prototype on is this kind of line see-through. So you have the ground and you are able to basically, like for example pipes, you can see them through the ground and also have like the context with the buildings and everything, but the lines will really be visible even if they are underground. And yeah, that's about it. In terms of visualization, we're working on other things, but they're not viz related, so I'm not going to mention them.
And I just want to point you to a few resources. So there's the resources I showed you in the documentation. Let's go back to that really quick. You have the samples, so you could search for smart mapping, go straight to the visualization tab, or you can go to the guide and you'll see this visualization tab here. So you get an overview and we talk about best practices, we talk about smart mapping, when to use it, when not to use it, how to manually define renderers. We talk about best practices for visualizing points with 3D symbols, things of that nature. A couple of years ago, yeah, it's been over 2 years now, I wrote this series on 3D visualization, working with all of these symbol types. It's it's clearly outdated. It's 2 years old, so a lot of the concepts are similar, but you'll notice some clear differences. And these samples that I have show different, are used with a different version of the API, though they should still be supported. So we just talk about these concepts, such as like draping and billboarding, and when you may or may not want to use it. So that's a blog series, 3 different parts, and I also talk about smart mapping in 3D and how you can build cool apps such as this one, exploring data with buildings. And I also wanted to point you to the Symbol Playground resource. If you've ever seen it before, it's helpful for 2D symbols such as this. But note that we also added the 3D symbols, and you don't see the previews here because that requires a symbol layer. So if I go into my point symbol 3D, switches to a 3D view, and I can add a symbol layer such as an icon, and I can change the color of the outline, or I can change, let's say, this is the material color. So here I can make it red, change the size, and you'll see the code snippet below automatically update. And so I can actually copy and paste that into my app. It makes it really easy for you. Note that it's already auto-casted, so you don't need to import any modules into your application when you do that. And just to give you another, so you can add other symbol layer types, but again, it may or may not make sense. If we change this to object symbol 3D layer, and then we can, maybe you can set an anchor that it deals with going above the ground or below the ground, and you can change the sizes here and work with them there. And again, you'll note that I find this helpful when we're talking about size, because you'll see that it takes real world units and not the screen units. Let's make this a easier color to see, so blue. So now you see that dome appear. Let's make it a little bigger, a lot bigger. So you'll get used to it as you play around with it, but again, you can copy and paste and bring it in there, change the base map so you see how it looks in different backgrounds. So with that, we'll go ahead and open it up to questions. So go ahead and raise your hand and we'll try to help you out. Yes?
Yeah, so you mentioned the feature reduction, but there's a selection. Is there a plan to have like custom feature reduction implementations? Like if I want to write my own prioritization algorithm for which features to have?
We don't support that. So we debated on this feature, I think, for 1 month because some people said, no, we should support it from the beginning so that people can actually set which features have priority. And we were like 1 month before release, and then we said, no, we're just going to do it based on how close they are to the screen. This is on our list, but I have to admit it's not super prio, so we're definitely not going to work on it for the UC. And currently it's not there, so you couldn't really do it.
But if you have requirements, by all means, come talk to us.
Yeah.
We're at the JavaScript island, and we'd love to hear your use cases so we can gather those and see how we can prioritize it. Okay. Yeah. If, in case you didn't hear, that's someone else has that same use case. So, anyone else? And if you guys have already created some cool 3D visualizations, we'd love to see them. You can come show us after. Also, come to the JavaScript showcase area, and we'd love to see what you've done. And if you have questions, feel free to walk up or come over to the showcase, and we'd love to chat. So thanks for coming out.
Thank you.